In this video, I will show you the simulation results of the code we wrote in the MATLAB, and we recorded that in the previous video. Unfortunately, there was some issue, and I read on internet that built-in feature of Windows actually records one screen or one Windows at a time. So when we simulate our simulations, the results, which are figures, they pop up in another window. So the results were not recorded. So simply I will discuss the results in this video. And if you are coming for the first time to this video and you want to see how we code this neural network, you can go to the another video in the same playlist or this course. So let's simulate our neural network. The values are same. We have 3 neurons, 2 inputs and 1 output. And learning gain I set to 0.1. So this plot is for the error, and the plot on the left hand side is for the approximation. So we can see that the error, it is actually not staying at 0. It crosses 0 occasionally, but it fluctuates and it is non-zero. The reason is that our approximation is not accurate. So we can see in this result that the real function, which is in blue color, it is not estimated accurately using the approximated function, which is shown using this dashed line. So what we can do in neural networks is that we can increase the number of neurons or tune our learning gain to obtain good approximation. So let's see what happens if we increase the number of neurons from 3 to, let's say, 10. So now we will do the simulations again, run the code, and it is taking more time because we have increased the number of neurons. So it needs more computational power. Again, you can see we have some error, a significant error in the beginning, but the error does not stay at 0. So again, we can see this over here, same issue. The approximation is not accurate, right? The function has started to learn learn the behavior of this function, but it is actually not approximating it. So let's increase the number of neurons even further to 15. Now you can guess in your mind that there is a mesh with 15 neurons, 2 inputs, and then there is an output. So you can see error is reduced from the previous case with 10 errors. Previously it was -3 something, now it is 1.6. But again, approximation is not accurate. You can see here. So there is an improvement in the result. The function has started to behave same as the real function, but still it is not accurate. So let's tune the value of learning parameter from 0.1 to 0.2. So let's see what happens. So now error is reduced even further and it stays close to 0. So our approximation is improved even further. There is another reason we are not obtaining the accurate results because of these timestamps or these instances. Let me simulate this for 1 second and you will see what happens. Before that, I want to explain. When we set this to 1, so the simulations will be performed for 1 second, 2 seconds, 3 seconds, and up to the final value. Okay, so you will see that our plots will be really strange. You will see this over here because they will be plotted very far apart from each other. This is the error. Even the real function, it is plotted at 0 second, then 1, then 2. So you can see these straight lines. Function does not know what happens at 1.1, 1.2, or 1.3. So this is another reason we are not getting good results. So what we can do is we can simulate our results at very small instances. Previously, I was doing it for 0.1, 0.2, 0.3. Let me set this to a very, very small value. Let's suppose 0.001. So now functions will be more smooth. Let's see. Yeah, we can see error stays at 0. Initially there is some error, but then it approaches 0 and stays there. And we can see our approximation. This is really accurate at this point. So this is about neural networks. We can see the results for 3 neurons. So I believe results will be good because we are performing the simulations for very small instances. And there are many iterations due to that, because in for loop, let me show you that. In for loop, you see it goes to length t, so 0.001, and for 10 seconds, this, I think this will be like 100,000 iterations or something like that. So when we simulate that and see the results, so error is at 0 and approximation is really good. Nonetheless, the key points to improve the neural network approximation is this tuning parameter and the number of neurons. Just to play around with it, let me set this to 1 neuron. Let's see what happens. Even I have not simulated this, so let's see what happens. So let's see. Again, it is performing really well because of the instances, and there are many linear combinations involved. So for example, there is one linear combination for 0.001 second at that moment. So all these combines together to achieve this result. So that's all, and thank you, and once again, good luck with neural networks.